In 2025, Earth will face a possible threat from space that could result in significant economic losses on a huge scale and cause confusion in the global community. This is a fact confirmed by NASA and other international space agencies. However, information about this has not been widely disseminated, as real problems often give way to more popular topics, such as theories about the Mayan calendar or Vanga's predictions. But serious scientists are already aware of the coming catastrophe and are preparing for it. You may have heard of some related events that hint at these problems. For example, you may recall the loss of 40 Starlink satellites to Elon Musk in February. Or maybe you're aware of the problems of the swarm network of satellites that suddenly started falling to Earth. Perhaps you have read about the event known as the Carrington Event, which occurred in 1859 and caused a temporary blackout of telegraph communications around the world, causing chaos on the planet for several days. All of these events are closely related and are harbingers of the disaster that is expected in 2025. And to make sense of them, we will begin by examining the role of Elon Musk. On February 3, 2022, a Falcon 9 rocket successfully delivered 49 Starlink global internet satellites into intermediate orbit. However, as early as February 8th, SpaceX announced the loss of 40 of those satellites. This is a serious financial loss for the corporation, considering that the 67th launch of the rocket was unsuccessful. However, what caused this outcome? Sun activity is to blame. The essence of the problem is the sun's electromagnetic activity, which manifests itself in sunspots and solar flares. Every 11 years, the sun's magnetic poles change places, which is accompanied by chaotic movements and overlapping magnetic lines. Where the magnetic field is disturbed, sunspots and regions of increased activity appear. As a result of this magnetic chaos and solar flares, huge amounts of charged particles are sent into space at superluminal velocities. In the case of satellites, they are exposed to these particles and the Earth's magnetic field, which can cause various problems. In this case, the Starlink satellites could not withstand the immediate effects of solar activity and were damaged. Near-Earth vehicles, including the International Space Station, ISS, are equipped with protection, but for the Starlink satellites, which have not yet managed to reach a stable orbit, protection against such effects was insufficient. The 40 satellites did not undergo an explosion or an anomaly that destroyed their electronics. They simply began to sink into the Earth's atmosphere, exposed to resistance and air density, and eventually sank. It is important to note that outer space is far from empty. Even at an altitude of hundreds of kilometers, small amounts of oxygen are present, and the environment becomes denser. The problem of losing the Starlink satellites is typical of all vehicles in Earth orbit. Interestingly, similar problems have been seen with other satellites, including the European Space Agency's swarm network of satellites that have been studying the Earth's magnetic field. Their rate of decline has increased several times, indicating the increasing density of the environment around the Earth due to solar activity. Thus, the problem of losing satellites is related to the activity of the Sun and the effects of solar flares on the Earth's orbit. Scientists have been studying solar cycles for a long time and are aware of such phenomena, but accurate prediction of their effects remains a challenge. In the context of this topic, the 11-year solar cycle is particularly interesting since the current problems both in space and on Earth are related to it. The root of this situation lies in the electromagnetic activity of the Sun. Approximately every 11 years, the magnetic poles of our star change places, creating magnetic lines that are chaotic and resemble works of art by Impressionists. These lines interact with each other, twisting, flipping, and colliding, creating sunspots, which are the areas of greatest solar activity. Without getting into complicated terms, let's go straight to the consequences of this magnetic chaos in sunspots. They manifest themselves as solar flares, which eject huge amounts of matter at superluminal velocities into space. A well-known example of these particles colliding with the Earth's magnetic field is the northern lights. However, there are also lesser-known effects, such as the atmospheric compression that causes the satellite displacement we discussed earlier, and the terrible geomagnetic storm of 1859. This event is also known as the Carrington Event, after the astronomer Richard Carrington, who observed the flares live. Usually we see the effects of solar emissions on Earth in a few days. After all, we are not just talking about light that reaches us in 8 minutes, but also about heavier particles. However, a couple or 3 days' journey from the Sun to Earth is very fast. Carrington, on the other hand, saw something even more frightening: a flare, after which a coronal mass ejection reached Earth in just 18 hours. This speed is due to the fact that the previous flares sort of cleared the way, and the solar superstorm swept the Earth much faster. Throughout Europe and North America, telegraph systems failed, and this was accompanied by strange phenomena, with even unplugged machines sending messages, giving off sparks, or bursting into flames. Northern lights, usually observed near polar latitudes, were seen even in Cuba and almost at the equator. Gold miners in the southern United States even woke up thinking it was morning and time to go to work. There was panic in many towns as people thought there was a fire. Of course, no magic really happened. The Earth was simply covered by a tremendous amount of solar wind. Part of this wind interacted with the Earth's magnetic field, causing the northern lights, and the other part created havoc with machinery and in people's heads. In 1859, telegraphs were rare, and people got around on horses. It wasn't about any internet, satellites, or television. Now, when you think about the sparkling telegraphs of a century and a half ago, imagine it in today's world. The downfall of Elon Musk's 40 satellites would seem like nothing more than a child's plaything. Our power grids, satellites, smart devices, and even the game Fortnite will be hit so hard that scientists cannot even predict the consequences. They operate only with rough estimates, according to one of which the damage to the Earth's economy could be about $4.5 trillion notionally. Why notional? Because not everything can be measured in money. On paper, GPS satellites cost a few $100 million, but that does not mean that satellites that fail will be replaced instantly. The same goes for power grids. They will have to be rebuilt not with money, but with labor and materials, which can also be damaged. All in all, things can be so terrible that it's scary to even think about it. So let's better turn to more specific mathematical calculations, going back to the 11-year solar cycles. When we analyze the graph over the past centuries, it is easy to see that these cycles roughly follow the same pattern. At the beginning of each cycle, the sun increases its activity, peaks, and then calms down. We are currently in the 25th solar cycle, which began in 2019 and is now reaching its peak. In 2021, the number of solar flares has tripled from quieter times, and that's just the beginning. If the graph, which has been repeated 24 times in the same pattern, is repeated for the 25th time, by 2025, the sun will have reached its peak of activity, and we can expect a storm comparable to the one that occurred in 1859. Here, the most observant might ask the logical question: 24 cycles have passed and peaked during our lifetime. So why haven't we noticed anything? The answer is not too reassuring. Generally speaking, we did notice. We just got lucky. On July 23, 2012, there was an incredibly powerful event, a coronal mass ejection of the sun, comparable in amplitude to that of 1805. However, due to the lucky location and the rotation of the Earth, we avoided collision with this projectile of the apocalypse. If the flash had occurred only 9 days later, it would have been aimed directly at our planet. Thus, we can say with certainty that superflashes are not fictions, and mankind has had the good fortune to make do with only a small difference in time. Older records indicate that earlier events associated with solar activity may have been less destructive because of the technological limitations of the time, or simply because they occurred during a period of a less active sun. However, we now face higher stakes, as our technological dependence and humanity's cosmic expansion occur during periods of increased solar activity. Here we can notice some interesting facts. A mini end of the world could indeed happen in 2012. And another funny feature is that the heyday of space activities, including private SpaceX satellites, Mars rovers, and space programs of various countries, came during a period of relative calmness of the sun. Even Neil Armstrong's crew to the moon narrowly avoided a solar flare. Thus, we are very fortunate that events unfolded the way they did, and can only blame fate for our bad luck. However, there is some good news. Single strong solar flares are only a special case of increased solar activity. The stable effect of such activity is related to the compaction of matter in the Earth's orbit. And here we have an additional advantage. Such activity helps to deal with the problem of space debris. There are already a large number of failed satellites and debris in orbit, and increased solar activity will make it harder for them to drift and help burn them up in the atmosphere. Moreover, increased solar activity will allow more money to be allocated to combat global warming. While this is a joke, it does emphasize that the effects of solar activity should not be dramatized in the space field. Organizations like NASA and SpaceX are doing research and developing new space programs for a reason. They have long known that there is no such thing as bad weather, only bad preparation. The Artemis mission to the Moon, the new Starlink satellites, and other programs are designed to account for increased solar winds and flares. There are special organizations that monitor space weather, and we now have the ability to respond quickly to solar outbursts and make necessary adjustments to the spacecraft. In July 2023, 115 large sunspots are expected, some of which could create localized disasters and remind us of our insignificance in the universe. On the scale of the solar system, our internal problems seem insignificant, and to the galaxies, we are nothing but ashes. Perhaps such events will help us realize the importance of humanity coming together to solve global problems.